Hello guys, welcome you all to the fifth session of Pandas data frame. And as per our regular practice, we used to do every day because there is a dependency of every sessions with the next session. So what I'm going to do first, I have already done this. So you guys please do this. Just create one file by the name day5.ipynb file. Then import this pandas and numpy here. So let me execute this. And after that, you need to create one variable nutrition and read that data frame, this nutrition.csv data frame. You have to read this and store it inside this variable nutrition and then run that. And after that, I am just accessing this nutrition.head. So is this thing fine for you? Now, let's come to the main topic. So during the last session, if I will go to this part, the fourth session, what was the last thing that we have done here? Since there is a duplicated column, so we have removed that. So I will be using the same thing here also. So that's why I am copy pasting it here and removing this duplication. And if again I will access this nutrition.head, let's see what I am getting. I am getting now the duplicated column get removed. Fine. So this is my data set right now. So let me introduce a very nifty way which we will use to conveniently take random samples from our data set. So what I want, this is my data set and this is the first 5 rows I'm getting from this data set because I have done nutrition.head. Now I want to take a random sample from our data set. And I already know that this data set, my original data set, is having how many rows? It is having 77 columns. And I suppose if I will write nutrition dot shape, let's write nutrition dot shape. What I will get? I will get 8,789. That means I am having this number of rows and this number of columns, 76 columns, and this many number of rows I am having. So I want a random sample. That means I want simple one complete row, random row from my data set. So for that, what I need to do, there's one method that is called random method. And this method is it is very simple. So what we call it, we call that method, the sample method on a data frame, and it will return back a random record. So this is my data set, nutrition. And if I write dot sample, sample sample, simply this sample method. And if I run this, I'm getting one random sample from my data set. This data set from the nutrition data set, I'm getting only one random sample. And this is a random record. Or you can also say this is a random observation. Random record or random observation. Let me write here. Random record, RECORD, or observation. Observation. If let's say this is, let's say if we call it again, this method, can you see? I am getting, this is a row number that I am getting. This row number is 4569. I am getting a record from this row number. If let's say if I will again run this nutrition and dot sample, so it will again give me some random sample. And it is not necessary that that sample will be same as my previous sample, because from the entire row or entire set of data, it is picking one random row and throwing me as an output. So this time I am getting some other random sample. This time I am getting some another random sample. And if I again do, let's say, if I again use this, if I again use nutrition dot sample, again I will get something else. This time I will get something else. And since this data set is very large, so the probability of getting the same random sample twice is very low. That's why every time I am getting something else. So what I need to keep in mind, this is supposed to be a random. So if let's say, if you get the same food entry that I am getting right now, same entry that I am getting right now, so it's only a coincidence, because that means we are cosmically connected somehow. But most likely your output will be different from mine output. You must have got this. Varun, are your output same or different from mine? Can you please confirm?
Different.
Fine. So what I was explaining you, this is all this you understood. Now there is a way to guarantee that this random method returns the same output for both of us. And that is if we provide the same random state. So there is one way. Right now, we all of us are getting different output. That means as a sample, we are getting different output. But if we, let's say, if we give some, there's one parameter inside this called random underscore state. This parameter, can you see this parameter, random underscore state? So if both of us will use the same number, we then in that case, we will get the same output. So let's first write this random underscore state parameter, and I am writing 12, and you guys should also write 12 and see, are both of us getting the same output or not? So let's run this. See, are you getting the same output what I am getting? And please confirm me.
Yes, sir. Same.
So what this random underscore state parameter is basically doing, if we both of us will use the, and it's not necessary that I'm using 12 or something. If I will change this something else, let's say instead of this 12 I will write 20 or something else, and even you will write the same thing, then in that case also you will get the same output as I'm getting. And matlab, you should know, till both of us are using the same random state, both will get the same output. If we use the different random state, then in that case we get the different output. This is one thing. Now this second thing is that when I am using this nutrition dot sample, what actually I am getting a one random sample. I am simply getting only one random sample. So there is one parameter inside this called n. And by default, the value of n is 1. So if I increase the number, let's say I am writing n is equal to 3. By default, n is 1. And I have changed this change the number to 3. If I will again run this, in this case, I am getting 3 random sample from this entire data set. And it is, can you see, I am getting three different samples. So this is how you will get, in this way, whatever number you will put here, you will get that many number of random samples from your data set. Even you can use the fractional value. Let's say instead of this sample, nutrition dot sample n is equal to 3, if you write some fraction, let's say instead of n is equal to 3, if I am writing frac is a parameter, can you say frac is a parameter fraction? So let's say I am writing 0.01. 0.01 is basically 10%. So I'm giving it a fractional value, percentage value, let's say. So what I'm asking to give me 10% of the sample from this nutrition data set. So if I will run this, I will get the 10% of the sample. So 88 rows is there. That means if you multiply this 88 into 10, to 8,800, something like that, 8,880 will come, something like that. So we are getting 10% of the sample here. So this is how you can also use the fraction to get the percentage data set, percentage sample from the data set. Any percentage that you will mention, you will get that. Now, after that, let's say if I will use, if you let's say put here nutrition, please wait. So let's say if I write nutrition dot shape here, shape, what shall I get? I will get 8789. And let's say if you calculate the 10% of 8789 multiply 0.10, what you will get? I am getting 878.9. And that is equivalent to sorry, 10.01. You have to write 0.01. 1%. I am writing like let's say 1%. So because here I am giving this thing 0.10, 0.01. So here also I have to give 0.01. So it is like 87.89, which is almost 88. So can you see? I am getting this thing. Now, if let's say I will write instead of this thing, instead of this, if I will write here fraction is equal to 0.01, and let's say I will write n is equal to some values, let's say 10. Fine. And then if I will run this, I will get an error. Why I'm getting an error? Because it is throwing because I am not supposed to put both the parameter at the same time. Either I need to write this n value or I need to write this fractional percentage. We cannot write both things at the same time. If I write, I will get an error. So this I have done just to demonstrate you. Let's add a few code cells here. Now, so let's add few code cells here. Now, there's one thing that I need to write. Let me write here. One thing is called sampling with replacements or weights. Fine. So what I'm going to discuss here, sampling with replacements or weights. So let me first tell you this. So earlier we were using very simple methods in the previous that we have just now studied these things. We were using very simple methods. And now I wanted to quickly go over two key parameters here because I think they will be useful if we continue on to do with statistical work or analysis, the first thing is called sampling with replacement. That is called sampling with replacement. The first thing that I am going to discuss right now. And what this is basically, let me first write it here. Nutrition dot sample, and there's one parameter. Let's write n is equal to 3 here. And then there's one parameter called replace parameter, and I'm putting this parameter, let me true. And now let me discuss this, explain it, this thing to you. So the what this basically means is that whenever we sample records from our population, we replace that record so that the probability of picking the same item again remains unchanged or does not change. So what you need to think? You need to think of sampling as choosing something, let's say from a box. Let me open this to explain it to you. So let's suppose this is one box. Fine. And so you need to think of sampling as choosing something from a box. And there is, let's say, something present inside this box. Let's say something is present inside this box. And this box contains all the possible values in our population. So when we sample this, that means when we take something with replacement, that means we choose to put this record. This thing, let's say if I choose to sample, if I choose to take two items from here, let's say this thing and this thing, take out, and then we will replace it. Then I move that back inside this. Then again, I will choose two items. Then again, I will replace this. Then again, I will choose 10. Let's say this is my A, or let's say this is my B. And I will take A and B. Here, this is C, this is D, this is E. Like that. These are, let's say, different items here present. And let's say if I take this AB out, and then again put it back randomly, if I take two things from here and then I put it back, then randomly take two items from here, then put it back, then randomly put two items here, then I will take, just put it back. So what we basically doing when we are basically sampling with replacement. So we used to put this record, this thing that we just selected, back into this box, into the box. So another way to say this is that sampling with replacement makes it possible to pick the exact same record multiple times. If let's say this is A and this is B, I have selected these two items, and then I replace this. Then again, I am selecting two items randomly and then again replacing it. Then again selecting. So there is a chance that we can pick the exact same record, let's say exact same item A and B twice or multiple times. So this is known as bootstrapping in statistics. This is known as bootstrapping in statistics. So let me explain this bootstrapping in statistics. So let me explain this by another way. Let's say I am having A, B, C, D, E, F, G, E, H. I am having these items with me. Let's say I am having these things. This is my population. Let's say this is my population. And I want to take, let's say, 3 items from this. Randomly, I want to take 3 items from, just mix this up. And randomly, I want to take these 3 items from this sample. So let's say with replacement. So when I am taking 3 items randomly, first time, let's say I am getting D, then I am getting B, then I am getting, let's say, C. Again, I am taking this, and then I am putting all these things back, and again, I am taking this thing. So let's say this time I am getting E, B, and C. Again, I will take this. Let's say I am getting this B, C, D. So, and let's say if I am taking only one item at a time, so even it is possible that even this, if I am taking one first, I have to pick 3 items from here, and I am taking one item at a time. So what it means? Even there is a chance that, let's say, I am picking one A first time, then I am replacing it. Then let's say I am picking another item, so I am getting E. Then again I am replacing it. Then again I am taking one item, and it is possible that I am getting this A twice here also. So this type of sampling is called bootstrapping in statistics. And it is possible because we are sampling with replacements, and that's why it makes it possible to pick the exact same record multiple times. So if we have a sample, let's clear this output. Let's clear this. So if we have a sample consisting, yes, I got your point. Varun, I got your point. So if we have a sample consisting of, let's say, 6 different letters that I have just now given you, and then we sample with replacement out of that group, or in other words, we create a bootstrap sample, we end up possibly choosing the same letter more than once. So this is one parameter called replace is equal to true. So if I do nutrition.sample n is equal to 3, n is equal to 3 means give me 3 samples, and replace is equal to true means you give, that means I am putting this parameter replace is equal to true means you can take the same sample twice also, or thrice also, 3 times also. Out of these 3 samples, you can put this. But since notice this, because we are allowing a replacement, we could technically end up getting the exact same record 3 times in a row or multiple times more than once. But because our population is so large, it's close to around 9,000 records. So picking the same 3, even when we allow this replacement, is very unlikely. So I guess if we stay here all the night, and let's say if I do again, if I do again, so if I do again, I'm running it again and again. Every time I am getting a different sample, but nothing is repeated here. Although this is with replacement, that means it is possible that I may get the one sample twice here or thrice here. But since the population is so large, and if I stay here all night and keep retrying, maybe we get closer to picking the same 3. But again, it's very unlikely. But the key thing to remember here is that by setting or by allowing replacement, we allow for that low probability event. That means we allow for the possibility of choosing the same record or row multiple times, record or maybe row multiple times in our sample of this 3. Now, This is about the replace parameter. So you got the clarity of this replace parameter. Now the next parameter we will talk about is allows us to break through randomness assumption in this sampling process. So that is called the weighted parameter. And I suppose, so we must let's discuss this also. That will be a good idea. So this parameter is called weighted sampling. Let me write here WEIGHTED, weighted sampling. Fine. So let me explain this thing to you, weighted sampling. So if you, let's say, think about what random sampling means, it's simply saying that the probability of choosing any one sample or event from this set is equal with weights. So we break that because we label our sample with specific weights. Let me write here. So what this weighted sampling is basically, so what we can do here in this weighted sampling, we level our samples with specific weights. And then we take those weights into consideration when we do the sampling. It means the higher the weight, the more likely the sample will be chosen. So it is difficult to understand this by this. So let's take an example. There is many ways to use the weights parameter, but here I will simply create one Pandas series and I will assign it to the weight variable. So let's create for once weight variable, WIGS to weight variable, and then assign it to the pandas series, pandas dot series. And inside this series, in the data column, let's write data is equal to, I'm putting this data as, let's say 10, 10, 10, 1, let's say 2. And inside this index, let's put index is equal to 7, 17, 29, 5, 6. Let's use this thing. Fine. Now, if I will run this is basically a pandas series. I'm creating a weight here. So using this pandas series. So what basically I'm doing, I will specify the weights and think of this as relative weights because pandas will normalize them behind the scenes anyway. So these are my weights. If I will access it, let's see what these are my weights. These are basically my weights. And these are basically my index. I have assigned some random index here. Some random index I have assigned here. So these are my index and these are my weights. Can you see these three indexes are having the maximum weight, that value, that means weight. I have assigned these three indexes same maximum value, that is 10, 10, 10, and these two are having some lower weights. So what it will do, so I want these three values, basically these three values 10, 10, 10, to be very likely to be selected. These are the heavy weights. And then the next one to have a much lower probability. That means the weights of these three are maximum. So there's a maximum probability of selecting these, and the weight of these two are lesser. So there is a lesser probability or lower probability of being selected. And this last two have a higher but still relatively a small probability of being picked. So next to this index parameter, I will pass these values, and then this index parameter, I am passing these values, and that I'm interested in sampling by referencing their index levels. Now, in the nutrition dataset, in the sample, what I will do, let's write nutrition dot sample, fine, and n is equal to 3, and there is one parameter called weight parameter, weights. So inside this parameter, I am passing this weight. Fine. Let's pass this weight, WIAGHT weight. If I pass this weight, and then let's say if I run this, can you see this 29, this 6, and this 17? I am getting in first when I am selecting this sample, out of these three, two values that I am getting, two indexes, 29 and 17, I am getting the index which is having a more weight, 10, 10. Fine. And only I am getting one index which is having a less weight. So if I again do it, let's say if I again do this, if I again, let's say if I again run this, see what I'm getting. This time I am getting 7, 17, 7, 6, 17, 7, 6, 17, 7, 6, 17. Again, I am getting two samples from higher weights and only one sample from the lower weights, because it is giving, as soon as I have mentioned here the weights, so it is basically giving the higher priorities to the more weighted sample. From this sample, it is giving the higher priority to the more weighted sample. Let's run it again and see what I am getting. Fine. Again run it. Now can you see 17, 29, 7? 17, 29, 7. I am getting all the three weights to be the highest. If I keep on running this, so always can you see I am getting, every time I am getting two samples from the weights which are having the higher, from the index which are having the higher weight. So think of this weights as a way of expressing our preference for what we want to be sampled. But imagine that what we could do with this kind of functionality. For instance, if the index were another more meaningful field, we could sample using different weights depending upon the contents of the index. And in any case, I only wanted to point out that sampling in Pandas does not have to be random equal weights. We could allow or prevent replacement and even provide a specific weights to bias the sampling one way or the another. So this is how this thing work in Pandas. Now, one important thing is that if let's say this is all for the day, now we will be doing in the next session, I will be discussing how are random numbers generated in Pandas, and that I will be going to discuss tomorrow. So fine, let's meet tomorrow let's going to upload this to GitHub. Session of Pandas completed. See changes. Fine. So that's all for the day, guys. Meeting you tomorrow again. Thanks for watching. Keep smiling, keep learning.